Hey guys, this is Eddie the Magic Monk bringing you another proving trig identity practice question. So the goal is to prove the left hand side equals the right hand side. Now to do this one, to give you a little hint, it requires a bit of understanding on factorizing and expanding binomials. So hopefully you can do all that. So have a go at it and come back when you're done. Okay, so the first thing I'm going to do is you can see here on the bottom of a fraction here I have 1 plus sine theta. Now in order to get rid of a fraction so that I can turn it into just an expression without any fractions. Basically, it's easier if the bottom of the fraction is just one single term. So I want to somehow think of a way to turn the bottom of this fraction from two terms to just one term. And you can see here the way we can do that is we can use this expression here. If I rearrange this identity, I get 1 minus sine square theta equals cos square theta. Right, so I'm going to somehow use this to change the bottom of this fraction into just one term, which is cos square theta. So how do I do that? Well, what I'm going to do first is I'm going to copy this diagram and paste it down the bottom here. Okay, and then what I'm going to do is I'm going to multiply. I'm going to focus on the left hand side. So the left hand side is 1 minus sine theta over 1 plus sine theta. And with fractions, as you would know already, you can multiply both the top and the bottom, but multiply both the numerator and the denominator by the same number and the fraction will stay equal. So I'm going to multiply the bottom, the denominator, by 1 minus sine theta. Okay, and you'll see why I'm doing that in a second. But if I multiply the denominator by this number, I have to multiply the numerator by this number as well, so the fraction stays equal. Okay, so that's what I'm going to do to the left hand side. Okay, so what happens? Well, the denominator turns into, if I expand this, it becomes 1 and minus sine theta plus sine theta minus sine square theta, right? Using binomial expansion, I'm sure you would already know what to do with that. So then the denominator becomes 1 so minus sine theta plus sine theta cancels to 0, so the denominator becomes 1 minus sine square theta. And now let's work on the numerator. So if I expand the numerator, I get 1 minus sine theta minus sine theta plus sine square theta. So that's what the numerator becomes. And then the numerator becomes 1 minus 2 sine theta plus sine square theta. And now look what has happened to the denominator. 1 minus sine square theta is equal to cos square theta using this identity. Right, 1 minus sine square theta equals cos square theta. So I can now rewrite this as cos square theta on the bottom and the top is 1 minus 2 sine theta plus sine square theta. And now we're going to use the trick that we did in the previous tutorial and separate this fraction into 3 fractions. So it becomes 1 over cos square theta minus 2 sine theta over cos square theta plus sine square theta over cos square theta. Right, separating the one fraction into 3 fractions. Okay, now let's use some trig identities to convert each of these fractions. So 1 over cos square theta, well, which identity can we use for that? Well, have a look at this one here. I'm going to copy that identity so you can see it. So I have So I have sec theta equals 1 over cos theta. So if I square both sides, which you're allowed to do with balancing equations, then I get 1 over cos square theta equals sec square theta. So I can put that here, sec square theta minus, and now what can I do with this? Well, sine theta over cos theta is tan theta, so it becomes 2 tan theta over cos theta. Alright, because tan theta equals sine theta over cos theta. So if I cross out a sine theta and a cos theta on the bottom, then I will get tan theta, and I'm left with another cos theta on the bottom. And then I have sine square theta over cos square theta is tan square theta, right, from this same identity. If I square both sides, then I get sine square theta over cos square theta equals tan square theta. So that's why this is equal to this. Okay, now I'm going to modify the middle one a little bit more, so I will get 2 tan theta, 1 over cos theta is sec theta. Alright, remember one of the ratios. So 1 over cos theta is sec theta plus tan square theta. And now, using the formulas for factorization, right? If you remember this formula, a minus b squared equals a squared minus 2ab plus b squared. That works exact same way as this, right? Because we have a is equal to sec theta and b is equal to tan theta. So therefore I'm going to factorize this back into a minus b squared, so it's sec theta minus tan theta squared, and that is what we tried to prove in the beginning, sec theta minus tan theta squared. So that's what I have. Okay, thanks for watching, guys. Hopefully this was a challenging problem for you. See you next time.